the whole brain. No? It includes the cerebrum, cerebral cortices, the cerebellum, as well as the brainstem, a portion of the spinal cord actually. Okay? So as I've been mentioning or saying in the past, laboratory demonstration, always orient yourself. No? So here would be, just follow the probe or the pointer. So this would be the anterior pole, okay, and then this will be the posterior pole. As you can see, we have here the cerebellum. So this will be our guide to determine the polarity. No? So if you are seeing the cerebellum, that should mean that you are in the posterior pole. And anteriorly, you also have here the temporal lobe, which will always be pointing towards the anterior, the anterior pole at that. No? So you can also see here a portion of the brainstem, which we are finished already, and of course, as I mentioned, continuation with the spinal cord. All right, so clear but done. Okay. So you can see that the cerebral cortex is quite it's the largest portion of the brain. Okay, and it is composed of at least 4 major lobes and 2 minor lobes. Right? So 4 major lobes, what are they? You have the frontal, temporal, parietal, and occipital. So the 2 minor lobes which we will try to show this afternoon include the limbic and the insular lobe. Okay? Alright. And of course, part of this, the demonstration would be the cerebellum as well. Right? So wala pa kayong cerebellum kasi. And the basal nuclei, right? Which includes the thalamus and hypothalamus and the basal ganglia, right? So you can see that the cerebral cortex is composed of sort of convoluted structures, no? So you have the convolutions, which will be the gyri, no? And separated by sulci. Okay, so how do we differentiate? I think Dr. Rosales tried to give you some tip on how to differentiate which one is gyri and which one is the sulci. But for me, I just know that the gyri are the crests or the elevations of the cortical tissue, okay, which actually represent the cortical tissue, no? Cortical surface of the brain. And the sulci would be the furrows, okay, the furrows or the divisions of these gyri. No? So actually, the gyration is an evolutionary development to increase the surface area of the brain. No? The brain has about, the cerebral cortex is about 2,500 cubic centimeter surface area by this convolution alone. No? That is contained in a very small cranium, no? or skull, okay, or cranial bulb. All right. So again, so the gyri would be the cortical crest, and then the sulci would be the furrows, no? Okay. All right. So the brain is the cerebral cortex, and that is composed of two hemispheres. Alright, so you can see that very clearly on the screen. So you have a left and a right hemisphere. No? So they are not usually identical or mirror image of each other. And besides, there are also differences in the function that can be seen only in one hemisphere. For example, in language function, it is only located in the left. Right? Okay, so we'll try to point out what are these important structures that concerns language. Alright, so you can see again the cerebral hemispheres. So before we study the different lobes, it is important that we note for certain landmarks that are clearly or easily visible or identifiable on a gross brain specimen. Okay, so this brain, the dura and the pia arachnoid has already been removed. That's why you can see the gyri very clearly. But some areas, no, like this one, so you can still see some leptomeningeal membranes, okay, right? And actually in this portion, you can see arachnoid granulations here, right? Which are actually the area where the CSF drains, as you have probably heard in your lecture. So what are the important landmarks? So here is one. So you can see it here, the midline. So this is the interhemispheric fissure. Alright? So interhemispheric kasi dalawang hemisphere yan. No? So if you try to divide or part, so you can see the corpus callosum, no, at the middle, at the center, or below that. So it is not a complete fissure. So it is shorter in front or anteriorly and becoming broader posteriorly. Okay, I'm sorry, that is supposed to be the fact. So what is insinuated here, or what is seen here, would be the falx cerebri. No? So it is insinuated here. So it is shorter anteriorly and going broad posteriorly. So I'll try to show you the dura later on, no? So you can better correlate. Alright, so that's one important landmark. So going into another landmark which you need to identify would be this one. So here will be the lateral fissure or the Sylvian fissure. Okay? And then the Sylvian fissure actually divides the frontal, okay, so it is the frontal lobe and portion of the temporal lobe, no? Of course, part of the parietal lobe as well, which you will see in a while, right? So you can see, if you open up the Sylvian fissure, you can see another lobe there, which is actually the insular lobe, which we will talk about later, no? After we discuss the major lobes, right? So now we have the hemispheric and then the lateral or Sylvian fissure. So, okay, another important gyri would be the fissure would be or sulcus will be this sulcus. Okay, so you can see it's forcing antero and slightly going upward oblique, no, going posteriorly. Okay, so this is the central sulcus, no. So it's not a straight line, but it's actually kind of oblique, no? Okay? That does not really go through and through the Sylvian fissure, but there's an interruption there, which you can see. Alright? So the best way to identify this, because some of the brains may not appear very clearly like this, no? So you can see, you should identify this gyri, or the lobule. This is known as the paracentral lobule. No? So the central sulcus will not go all the way through the interhemispheric fissure, but will be interrupted by this lobule, which is the paracentral lobule. So the paracentral lobule is actually better appreciated sa medial section. No? Let's see. I'll try to get a sagittal cut so you can appreciate better.